Hello guys, welcome to Bugs in Code. The problem that we are going to solve today is update queries. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe my channel so that you never miss out an update. So let's get started. Here's the problem statement, and it says that you're given an array of n elements. Initially, all elements are equal to 0. Okay, you have to perform q queries. Each query contains three integers L, R, X, and you need to change the value of AI to AI or X. So it is OR operation for all I in range from L to R. Okay. Return the array after executing q queries, and we are also given one example here. So let me just explain the example, and I'm going to take this example. We are given n equals to 3 and q equals to 2, and we are given queries like 131 132. So let me just write the meaning to these queries, like this is the lower index, this is the higher index, and this is the value x which need to be added in the array. Okay, so I'm also going to take an array like this is the array. Since the n is equal to 3, so this array is having a size of 3. So what we need to do is from I equals to okay, so from 1 to index 3 I have to add 1. But interesting thing to note here is this is 3 and this is 3, so our higher index should be in the range from like in the array size. So it is basically following the one based indexing. So it is the one based indexing, and what I'm going to do is for this one I will start from 1 2 and 3. So I have to make from 1 to 3 elements as 1. So let's make it like 1 1 1. After that, what I need to do is I need to here. Okay, so here according to problem we have 3, and now what we are going to do is from this from 1 to 3 we have to perform like OR operation with 2. So okay, and what we are going to do is in the whole array, if I do 1 or 2, so what I will get, like here 1 is 0 1 and 2 is 1 0, so I will get 1 1, and 1 1 is nothing but like 1 plus 2, and it is 3. So I'm going to update all the values from 1 to 3 index with 3, so it will become 3 3 and 3, and this which is going to be our output. Okay, so let me even take one more example in order to explain the problem statement clearly. So the example that I'm going to take is n equals to 4 and q equals to 2, and I will have queries like 132 and 245. Let's see what we can do in this example. So we are going to have an array which is initially having 0, and after that I have to perform like this is lower, higher, and x. So from 1 to 3 I have to perform like OR operation with 2, and from 2 to 4 I have to perform OR operation with 5. So what I'm going to do is, first of all I'm going to perform OR operation with 2. So 0 or 2 is nothing but it is 2. So 2 to 2 I will have in this array, and after that I will have 0, and now I need to perform the OR with 5. So 2 or 5 is what, like 5 is 101 and 2 is 10, so it will become 111, and 111 is 7. So I will have 2, and when I do 5 or 2 I will get 7. Similarly I will get 7 here, and I will get 5 here because it is 0 or 5. So this is something which is going to be our answer. I hope you guys got the clear understanding of the problem statement, and now let me just move to the solution. Okay, so we are given an value of n, like which is, let's take 3, and we are given some queries, two queries, and we have an query array like 1 3, and we have to 1, and 1 3, and we have 2. Okay, so the first approach that comes in our mind is, so approach 1 is what? the first approach that comes to our mind is what we can do is we can traverse the whole queries. So traverse all queries and then simply do like perform operation from L to R. So perform or operation from L to R. So it's like a simple approach, and I will call it brute force approach. So because it is trying all the solutions, so it is brute force approach. And now without further delay, let me just code this approach. So what I'm going to do is, this is the problem on Geeks for Geeks. I'm going to provide the link in the description box. So let me just code it. So I'm going to have a loop. Even I'm going to have all the queries from you. So traversing all the queries, and I will even have an array which is going to store my answer. And now I will have a value L, which will be query of 0, and I will have value high, or I will say left to right, so R, which will be query of 1, and after that I will have a value which is X, so it is query of 2. Now what I have to do is from L to R, like I equals to L to I smaller than R, I'm going to perform the operation. What I have to do is I have to do answer of I equals to answer of I or X, simple. But since it is following one based indexing, then I have to do like -1 here, and instead of doing -1 here, let's do -1 at this point. So this is what we are going to do in this problem, and it's a simple approach, but let's see whether it's going to work or not. Let me just run it. It's showing compilation error because I have not taken integer here. Let's see now. Okay, so it's working for the example test case, and let me just submit it. Okay, so it's working, but it may give me time limit exceed. Okay, so it's giving me time limit exceed error, and why time limit exceed, let me explain you. So these are the constant to this problem, like you can see here. N can be 10 raised to the power 5 and q can be 10 raised to the power. And what about the time complexity of this problem? So it is going to be O of into q, and when we do n into q, why n into q? Because I'm traversing all the queries for like of n times. Now this n can be 10 raised to the power max, and this q can be 10 raised to the power 5 at max, and it is going to give me 10 raised to the power 10. But the question is, can my algorithm handle this? Like 1 second, the algorithm which has 1 second running time can handle at most 10 raised to the power 8 operations, but I'm performing 10 raised to the power 10 operations here, so that's why it is giving me time limit exceed. I hope you guys got the understanding why it's giving time limit exceed. So let me just move to the optimal approach. So let me just move to the optimal approach now. And okay, so my app is not working, let me run it again. So now let me start with the optimal approach. I will write here, I'm going to write here optimization. And what I'm going to do is, before moving on to the solution, exact solution, I will start with a very important concept. Like, let's take, okay, so this is something which is a requirement, so prerequisite kind of thing. So we are going to learn a very important concept here. So concept which is the basis for us solving this problem. So the concept says that let's suppose we have to perform OR operation, like plus operation, instead of this OR operation. So just forget about this OR operation which is given in the problem for now, and focus on this plus operation. So we have an array, and this array is containing 0 0 0 0 0 0, and we have to perform like we have to add 4 to all these element in the range which I have given here, and we have to add 2 in this range. So how we are going to do it? You may see the similarity between the problem which is given to us and the problem that I am telling you here, but just the difference is there we have OR operation and here we have plus operation. So we are going to do it for plus operation, and then I'm going to tell you how we can like use this approach to solve the given problem. Now, in order to perform operation, instead of doing like 4 4 4 for each like index, what I'm going to do is I'm going to store this 4 in the lower index. So I will have 4 here, and similarly for this 2 I'm going to store this 2 at the lower index, so I will have 2 here. After that I will have 0 0 0 0. Now what I'm going to do is I'm going to perform with something which is the prefix sum. So let me perform the prefix sum here, so it will give me 4. After that I will have 6 6 6 6 6. Okay, now you can see that if we write the output for this problem, then I will have like 4 4 4 here, and then these 2 will become 6, and I will have 2 here, like 4 6 6 2 2 2. This is what we are going, this is the original output. So this is the original output, and this is what we got. So you can see that till here we get the correct output, like till this point our output is correct. But what problem is happening here? So here something which is happening is the effect of this 4 is still here, but it should not be here. Why? The range is like from this point to this point, so we need to do something which will remove the effect of this 4 at this index and even after this index. So what we are going to do in order to achieve that? In order to achieve that thing, what we are going to do is, like, at this point we are going to store -4. So whenever I will do like I will do here 4 4 and -4, then it will become 0, and it will be 0 for further operations as well. So this minus operation is something which act as like a nullification operation for the plus. So it is like a complement operation. So in order to cancel the effect of this plus operation, we can simply do the minus operation. And let me just explain you what I mean when I say that. So like if I have an array like 0 0 0 0 0 0, and I have to perform 4 4 here and 2 for this index. So what I'm going to do is, here at the lower index I'm going to store like for the numbers, like I will store 4 at the starting index, and similarly for 2 at this index. Now just after this index, like when my range is over, I'm going to store -4, so that it will cancel the effect of like this 4 for the further calculations. So I'm going to have like 0 here and -4 here, and after that let's suppose the effect of, okay, so we are okay with this, and we are going to have 0 0 0, and then okay, so I will have 0 0, and then I will have -2. So -2 something which lies here. Even we don't write even if we don't write -2, then doesn't matter, because after that we don't have to do anything. So this is a, and now if I do now, so I will get like 4 6 6, and 6 minus 4 is 2 2 2. So this is what was our real answer. So this is our real answer. You guys understood what I'm actually saying when I make the statement that I can store, like, answer of lower can be stored with the value x, and answer of higher index plus 1 is going to have the value -x. So this is for zero based indexing. Zero based indexing. For one based indexing, I'm going to have a of lower -1 as like x, and a of higher as my max. So a is basically my answer array, and whatever I have told you till now is only applicable for the plus operation. Why for plus operation? Because minus operation is thing which act as so minus uh, acts as like nullification for the this plus. I'm not sure when I say nullification operator, so I'm right. But I hope you guys understood what I'm actually trying to say. I'm trying to say that minus operation can cancel the effect of this plus. So minus can cancel the effect of plus operation. So that's what I want to say, and that's why we're doing like minus x after the range. This is what we do for the plus operation. And now I want you guys to note this concept something in your somewhere in your copy, because operation is something which is going to play a major role in order to solve the problem that is given to us. So after we have completed the concept, let's move back to let's move back to our original problem, to our original problem original problem. Now you have understood a very important concept, and I'm going to use that concept. So what we are given is we are given some queries. Let me use this. So we are given some queries like n is equal to 4 and query equal to 2, and we are given queries like 1. Okay, so how we are given queries 1 3 1, and I have 1 3 2. So this is the first example, and let me take some other queries. Like I'm going to take 1 3 and 2, and then 2 4 and 5. Okay, so I'm going to have an array. Like this array is something which is okay. So let me take an array. Okay, so I have an array, and this array is initially containing 0 0 and 0. Now from index 1 to index 3, like here I have to do OR with 2. So now we are back to our OR operation, and from this index 2 to index 4 I have to do OR with 5. Now what I want is, if I use something like prefix sum. So in the prefix sum, when I store 2 at the starting index and I do OR with further like digits. So what I want is, I want the effect of this 2 get cancelled out when I reach this index. So is it possible? We can make it possible, but it is actually not possible for OR operation. But it is going to be very interesting to see how we are going to make it possible. Just be with me and see what I do here. So okay, instead what I want is, I want to have this example. So let me just okay, so let me just select it and like store it here. Okay, so I hope this example is still clear to visible to you. And now what I'm going to do is, now I'm going to do something like, which is, instead of storing these element as the number, we are going to store these element as the like in the form of something similar to bits. I'm not saying bits, I'm saying something similar to bits. Let's see the difference. For like uh, for the like here I have 2, but instead of 2 and 5, let's take like okay, so instead of this 2, let's take it 7, and let's take in 9. Okay, so what we are going to do is, we are going to store 7 in the first index, but in the form of something which is similar to bit, like 1 1 1. We have stored 7, and after that 0 0 0 I will have. After that okay, so it is a first index, so I'm even going to store nothing but 9, 1001. So let's remove this. After that, I'm going to store like 0000, and after that I'm going to store now this 0 is something which is out of index for this 7, so I'm going to store -1 -1 -1, very important thing, and 0. And after that, since I am out of bound for the array, but still for your understanding, let me store here like -1 0 0 -1. Why I have stored this? Because this is out of bound for this 9 and I am going to store in this form. Now it is very important that it is very interesting that how I am storing this -1. So that's why I'm saying these are not bits, and when I do 1 plus -1, then this get cancelled out when I do prefix sum. So now I'm going to do something. So this is the first operation. I want you guys to notice these things. Down these things in your copy. So the second operation is storing values. Now you can relate this operation to something that we have done, like a of low to be x and a of high plus 1 is going to be minus x, isn't it? So you can relate this thing to the operation that I have explained the concept before. After that, we are going to do something which is equal to prefix sum. Now prefix sum, let's see how we are going to do prefix sum. 1 1 1 0 for the first one. After that 2 1 1 1. After that I will have 2 1 1 1, no doubt. After that I will have 1 here, I will have 0 0 and 1. And okay, this is for now because this is something which is out of bound for the. Now these are the two steps that we have done, and now we are going to do a last step and even third index, which is convert values. How we are going to convert values is like this value can be converted to the original value. How? But like we convert in the binary format, like this is 1, so 2 raised to the power 0 plus 2 raised to the power 1 plus 2 raised to the power 2 plus, you can see it is 0, so it is not going to give any value, so it will be equal to 7 for the first index. After that I have 2 here, but actually this 2 is of no significance, it is just similar to 1. Why I am saying that, let me explain you. I have 1 1 1, like I have 1 0 0 1 and I have 1 1 1. When I do plus operation, when I do OR operation for these 1 and 1, then I get 1. Even I have multiple 1 1 1 1 and I do OR operation of all these, then still I will get 1. So doesn't matter how many ones we have, we are just going to have the impact of 1. So, and this it signifies that we have two ones here, and two ones are going to give me 1, so it is going to give me 1 plus 2 plus 3 plus 4 plus 8, so it is similar to 15. Similarly, it is equal to 15, and now it is equal to 9. So this is something which is going to be our answer. I hope you guys got the understanding what I'm actually doing here. So these three steps are very important. If you don't get the logic, then watch the video from this particular part again. This is something which is very interesting concept and even used in multiple problems, like the concept that I have to for the plus operation. And even you can see that how I'm applicating the previous concept, and I don't I'm not sure even if you are able to relate this logic to the previous like how we are storing values, how we are doing prefix sum, and the value is something which is based on this option. So now I'm just going to move in the code part, and let me move to the coding part. So this is the problem, and I'm going to reset the code now, and I'm going to code the problem here. So let me just remove this line. Okay, so let me start. I'm going to have an array which is nothing but which is going to be your help array. So it will be size n plus 1. Why n plus 1? Because I will tell you later why it is n plus 1. I'm going to have actually, let's take 32, because what's the maximum bits which can store all the integers? It's actually 32 bits. So in 32 bits we can have all the integers, but since here the range is given like to the power 5, so let's check what is the value, what is the maximum number of bits that can represent 10 raised to the power 5. So let me randomly collect. Okay, so 2 raised to the power 7. Let's check for 2 raised to the power 7. 17. So 2 raised to the power 17 is something which is going to give me 1,31,000, and if I do 2 raised to the power 16, then it will give me something which is like, let's see what it gives me. Okay, so it's giving me 65,000, and I'm going to move with, okay, 17 is okay, but I'm going to take here, let's take 20, because 20 is something which will surely work. And now what I'm going to do is I'm going to, okay, so let's relate with this board. Here what we have is we have a 2D array. So the 2D array is like, this is our 2D array, isn't it? Now for this 2D array we are having rows as this value, like column as these value and row are storing the binary form. So what I'm going to do is uh, and here what I'm doing is like I'm storing the numbers in the row and I'm storing bits in the column. Okay, so it doesn't matter, just I'm so with, and what I'm now going to do is I'm going to have my queries in the query array. So I will have my something which is L, and L is query of 0, and then I will have my R which is equal to query of 1, and then I will have my X which is query of 2. Now I'm going to have an index, uh, let's name it IN, and what is the use of this index is, let me tell you what is the use of this index. This index is something which is going to point at this value, like index first will be at this point, then will be at this point, then will be at this point, and it will store these one. If the value is 1, then it will store here. So let me just traverse the binary form of the current number, and what I'm going to do is if my x mod 2 is equal to 1, only then I'm going to store 1 somewhere. So somewhere is store 1 at like this, and as well as this minus value will be stored at this higher plus 1 index, and at lower index I will store 1. So let's do it. I'm going to help of like lower minus 1. Why I'm doing minus 1? Because it is following 1 based indexing, and in plus plus, and after that help of like higher is going to be minus minus. After that I'm going to increase my index, and I'm also going to divide my x by 2. This is what we have to do. So I have done one step. So this step is nothing but storing values. Like, I hope you guys have noted down whatever I have told you in the video. So I'm just going to relate all the operation with this code. So now I'm going to do something which is like prefix sum. See how I'm going to sum. I'm going to like start a loop from for all the like columns, and all the columns are storing the bits, something similar to bits, not exactly bits. So I'm going to have my j equal to 1 by 1, because for 0 it can cause index out of bound error. Why index out of bound error? Because here I'm going to do something crazy, like array of j I equal to help of help j minus 1, which is really something which is dangerous when I start with 0 here. So after that I will have something which is I, so it will be plus here. Now with the pre operation as well, Prefix sum operation plays a very important role. Why? Because here you can see that when I do prefix sum, then here get cancelled out. Like the effect of 9 will be right here. 4 I repeat. Like 7. Okay, sorry, it's 7, not 9. So that's what we are doing here. And let me just now do my final step, which is converting values. So I hope you guys are able to relate whatever I have told you in the problem. So now let me just do something like for I equal 0, I smaller than n I plus plus, and I'm going to convert the current value. So for that I need a variable to store that value, and I'm going to traverse like j equal to 0 like okay. So instead of doing 17 here, let's do, since we are having 20 as our index, so let's do 20 and j plus plus. Now what I'm going to do is, if my bit is not equal to 0, like as we have checked for 1 and 2, so if my help of ij is something greater than 0, then we are going to do value plus equal to 2 raised to the power j. So j is my current index, and one left shift is nothing but 2 raised to the power j. After that I'm going to what I'm going to do is I'm going to store simply it in my answer, and I'm going to answer, but where's my answer? So I'm going to create an answer array here. So int answer is going to be my new int, which is of n size. So let's see whether it works or not. Okay, so I'm going to compile and run it. So I have basically broken down the problem in 3 steps, and even 3 easy steps. If you watch this video carefully, then you will surely be able to solve this problem easily. So let me just run and check it whether it works. Okay, so it's working for the example test case, and let me just submit it. Okay, so the problem is working, and this is all about this problem. I hope you guys got the clear understanding of the problem.